Hey everybody, it's Mr. Francis. Doing a little something different here for the review for Chapter 11. I'm really going to go the highlights instead of going through all the slides. Chapter 11 focuses on solids and liquids. And what I want you guys to focus on with these two physical states, first and foremost, is the terminology. And there is a lot of terminology in this chapter from with the liquids in terms of the types of properties, vapor pressure, melting point, boiling point, to solids, looking at hardness and conductivity, and all that. So pay attention to the terminology that you see with this. With liquids, two areas aside from the terminology that we see with it. First and foremost, there is the transitions that occur within the liquids. And we're familiar with it, freezing and melting, boiling and evaporation. But within the chapter, they focus on what they call a heating curve and a phase diagram. With phase diagrams are not that difficult to understand, because now what the phase diagrams do is give you all the temperature and pressure conditions that you see for a substance. So when you see the first phase diagram for water, it's going to look really strange. But what you want to focus on, the temperature and pressure conditions where water's in the solid state, where water's in the liquid state, and then where water is in the gaseous state. And that's going to help you understand it a little bit more. And then also go into some of the terminology within the phase diagram, primarily triple point and critical point that we see with it. Also with liquids, we talk about the intermolecular forces. With gases, one of the things we noted is that substances in the gaseous state have very little, if any, intermolecular forces. In liquids, intermolecular forces are the key, and that's what holds those molecules together in the liquid state. The key with intermolecular forces is what type of intermolecular forces do we see for what type of liquid. And it's all going to be based on what makes up that particular substance, whether it's dipole forces, London forces, or hydrogen bonding. So again, look at the terminology and look at the distinction between each of those. For solids, what I want you to focus on is obviously crystalline and amorphous solids, but with crystalline solids, the types of crystalline solids as we go from molecular solids, ionic solids, metallic solids, and covalent network solids. And each of those four crystalline solids, what I want you to focus on is, one, what makes up each type of solid in terms of the particles, in terms of the substance, and then two, what's holding those molecules together? What's holding the molecules within a covalent network solid together? And then once you're able to identify those two things, the properties that we see with solids in terms of conductivity, in terms of hardness, in terms of melting point and boiling point for a substance in the solid state, that all starts to make sense. Okay. The last part of chapter 12 gets into when we start looking at the microscopic, at the atomic level, the arrangement of the particles in what we call unit cells, and then unit cells building up into a crystal lattice, and that crystal lattice building up into the solids that we see with it. Okay, so that's what I want you to focus on in this chapter. It's a little different. Like I said, I'm not going to read through the notes that we've seen previously. I'm going to have this, so continue working on it. The last thing I will add today, 2 weeks. We have 2 weeks and then it's finals. Okay, so plan the schedule accordingly. Know your calendar, know everything that's going on. With that, take care, and I'll talk to you guys soon.